Welcome to Owie and Sandy Math Along. I'm Sandy.
And I'm Owie!
Number 6, we are given a parallelogram and we are given some of the lengths in that parallelogram and asked to find the area of the parallelogram. So we are going to look up area of a parallelogram, or if you're me, you just kind of know it. You guys are used to the area of a triangle being 1/2 base times height. A parallelogram is just base times height. There's no half. Okay. It's essentially like taking length times width, only we're looking at height, okay, and length. So we have base, okay, that's our length down there, is 7 times our height, and we get 28. Everything's in centimeters, so that means we have centimeters squared. Whew, that was really easy, right? If you don't know that formula, then you could break this up, okay, into two triangles. This triangle and this triangle are going to be identical to one another. You can find the area inside of this square. 4 times 4 is 16, okay, length and width. And then for the triangles, 1/2 base times height, okay, which ends up being 12/2 or 6, okay. That's identical. 16 plus 6 plus 6 is going to equal 28. You get the exact same thing, centimeters squared. And I'll accept either way on the assignment, that's fine. But when you sit down for an EOC, depending on what formulas you're given, what you remember, it's perfectly okay to do it this way or that way, because if you notice, we got the same answer either way, which is right. Number 7, we are given rhombus ABCD. We are given the lengths of both diagonals, and we're asked to find the area inside the rhombus. They do specify we're working in centimeters, so our answer should be in square centimeters. There are 2 ways you could go about this. The first way is there is an equation, a formula for area of a rhombus. The area of a rhombus, I'm going to draw it like that, is PQ over 2. And y'all are going to be like, PQ, like what are you talking about? Well, what we're talking about are the diagonals. They call P and Q, okay? So all we have to do, and yes, excuse me, that's how I write my Q's. Deal with it. Okay, our area is 20 times 28 divided by 2, or 560 over 2, which comes out to 280. Okay, centimeters, and they are squared. Easy enough. Now, if you forget what the formula is, or you're taking a test where they don't give you the formula, you could also just find the area of one of these triangles and multiply it by 4. So I am going to run through doing it that way. I know if you're watching this for the sake of just getting your homework done, you are going to skip this part, but this really might come in handy if you're taking an EOC. So if we know AC is 20 units long, that means each part of this is 10. And with the 28, we know each part of this one is going to be 14, okay? Half of the total length. So area of a triangle, and that's one you all have memorized now, I hope. All right, base times height, base 14, height 10. So I get 7 times 10 or 70. And then there's 4 of those triangles. So I'm going to multiply times 4 triangles. Also gives me 280. And then they want us in centimeters squared. Okay. So either way you do it, it's not that hard, but it's a matter of which formula you would rather work with, which formula you remember, and what formulas are given. Number 10. Number 10 is a circle with a shaded region in it. They give us the radius of the circle minus 16. Mine is 16, not minus. And they ask us to find the area of the shaded region. The shaded region looks like a triangle to me. Okay. We have a 90-degree angle that's given to us, and we know our radii. Okay. The 2 radiuses are 16. And we want the area of that shaded region, area of a triangle, 1/2 base times height. Now, looking at this triangle, I don't exactly know the base or the height, do I? What I do know is it's a 90-degree triangle. That's a right triangle. And I could split it down the center, okay, giving me a 45 on either side, a right angle at both bottoms. Remember, all angles in a triangle add up to 180, so 45, 45, 90 would equal up to what we need. A 45, 45, 90 is a special triangle. So in a 45, 45, 90, whatever one of our legs is, the other one has to be the same. And the hypotenuse, we already know, will be that leg length, that side length times square root of 2. Just the way it is. We'll talk about that in class a little bit more. So I know this hypotenuse, okay, that's our hypotenuse of that triangle. It's across from the 90-degree angle. 16 is equal to whatever my side is, okay, whatever my base is. I'm going to call it B for base, all right? B times the square root, and I wrote 3, 2, okay? Solving for B, B is equal to 16 over square root of 2. So it's a little backwards from how we wrote it up there, but that's because what we were given was the hypotenuse. And so it already had that square root of 2 rolled into it. Okay. So down here we have 1/2 base times height. The height is here. And again, our height and our base are going to be equal to the same thing. It's a 45, 45, 90. So 16 over square root of 2. Multiply straight across. 16 times 16. Sorry, I don't have it memorized. I probably should. I should. It's 256. I think I knew that somewhere in the depths of my mind. Now we have 2 times the square root of 2 times the square root of 2. The square root of 2 times the square root of 2 is just 2. So we have 2 times 2 is 4. 256 divided by 4 is going to be 6. And then you have a 15. And then 4 goes into 15 3 times, which is 12. Which gives you a 3, 6, 6, 39. What's our measurements? Did they say our measurement? Is it centimeters again? They did not give us measurements, so it's just 639 on mine. Number 12. For triangles above, the area of ABC, this one, is twice the area of triangle DEF. And then it says, if ABC is equilateral, what is the perimeter of ABC? So we are given a couple of values here for DEF. And again, we know that ABC is twice the area of DEF. They also tell us ABC is equilateral. I'm going to draw on those little tick marks. And what that means is they're each congruent to one another. They're all the same measurement. And we want to find the perimeter of ABC. Well, we're going to start by using this first clue they gave us. Now, I do want to note clearly when we look at this, ABC does not look twice as big as DEF. These images are not to scale, so you cannot rely on just looking at them. You actually have to go through the math to figure things out. So our area of ABC, twice this area, we're going to find the area of DEF first. So the area, I'm going to write DEF, 1/2 base times height, 1/2. Our base is right here, the 7 square root of 3. And our height, okay, from the perpendicular angle up to the vertex is 7. So we multiply straight across. 1 times 7 square root of 3 times 7 is 49 square root of 3 divided by, the only thing in our denominator is the 2. Okay, so we're just going to leave it like that for the time being. I know it looks a little messy, but if we put that in a calculator and get a decimal, it's not going to be as exact as leaving it this way. Okay, so we know that the area of ABC is twice that. I'm going to go ahead and put that here. I'm going to say 2 times 49 square root of 3 over 2. Now, if you notice, because that's over a 1, if there's nothing else there, this actually just kind of cancels out. So it just becomes 49 square root of 3. Okay, that's our area over here of ABC. Now, the reason that's important is because now we need to use that area to figure out one of these sides, or, we got to figure out something, right? So to find the area of ABC, we have to have 1/2 base times height. So I'm going to draw a line here that represents height. Okay, that's our H. Another important thing here, if this is equilateral, it is also equiangular. Okay, so each angle on an equilateral triangle is always 60. They have to be the same as each other, and they have to add up to be 180. Well, then why did I write 30? This is a bisector, okay, perpendicular bisector actually, and it bisects this angle up here into 2 equal angles, 30, 30, okay? So this is actually a 30, 60, 90. We have a special triangle. Let me that up next to myself there so that can remind you of the formula that we use. On a 30, 60, 90, whatever our base is, I'm going to call it B for base. I hope that doesn't confuse anybody, okay? Twice the base is our hypotenuse. Remember, hypotenuse is always across from that 90-degree angle. That's our slanted line there. Okay, and then B times square root of 3 would be our height. So instead of H, even though that's our height, I can represent it with square root of 3, B. Right? I hope you can see that. I hope the camera is, good enough for that. Now, our formula then for the area of ABC, 1/2 base and height. Our height is square root of 3 times B. This is equal to 49 square root of 3. Remember, twice this, okay, is the area of ABC. So we can set this new formula we figured out equal to 49 square root of 3. All right, let's simplify over here. 1/2 times square root of 3 is the square root of 3 over 2. Okay, or you could look at it like we're just multiplying straight across. 1 times b times square root of 3 times b, which also gives us b squared, because b times b is b squared. So this is our simplified version of this side, equals 49 square root of 3, and I want to solve for b. Okay, you can cross multiply. You can multiply both sides by 2. I don't care which way you look at it. I'm going to go ahead and do the cross multiplication. Remember, this is over 1 if there's nothing else. So I have square root of 3b squared is equal to 49 square root of 3 times 2. So 49 times 2 is 98, and we still have square root of 3. All right, so I'm going to move the next step up here. But what I noticed, they both have a square root of 3 in common, and I'm going to divide by the square root of 3 because that's what is times b, and I want to get b by itself. Okay, so this cancels out on both sides. I get b squared equals 98. B then is the square root of 98. That means half, okay, of our base here. That's what we call b. This part right here is the square root of 98. The other side would also be square root of 98. So we have 2 times the square root of 98 for the whole thing. And every one of these sides is the same. Okay, so we're going to add all 3 up to get our perimeter, which is what they want us to do. I got to pause. I had a phone call. I'm back. Okay, so now we have to add up all 3 of these sides. 2 square root of 98 plus 2 square root of 98 plus 2 square root of 98 equals. Remember what I've said the last couple problems. If you have that square root in there, that radical, you treat that kind of like an x. Okay, I have 2 square roots of 98, 2 more. That gives me 6 total square roots of 98. Okay, I don't believe 98 can be reduced anymore, so that is our answer. Okay. I'm thinking of perfect squares that could possibly go into it. So, 4 does not, 9 does not, 16 does not, 25 does not, 36 does not, 49, oh, well, duh. Okay. So, I want to erase all that work and then show you how I did that. It would probably be better for me to edit the video. I don't know that or not. We'll see what I feel like. Okay. Square root of 98. 98 can be broken down, I'm so silly, into the square root of 49 and the square root of 2. So that becomes 6. The square root of 49 is 7. Square root of 2. 6 times 7 is 42. So our answer is square root of 2. Okay, 42 square root of 2. So when Owen watches this, he's going to be like, because back when I first got the square root of 98, I probably should have changed it then. It's okay that we didn't. Got the same answer as we would have anyway. But Owen would not stand for this. Number 13. A bicycle wheel made 600 revolutions while traveling 10,000 pi inches in a straight line along a trail. What is the diameter in inches of the wheel? We're looking for diameter. All right, so let's look at this bicycle wheel and let's make this problem make some sense. As you pull forward on a bicycle, you go in a straight line. So this distance they're going is so many times the circumference of that tire. If you want to think of it this way, imagine we coat a tire with paint, okay? And 100% of that paint comes off as soon as it touches the ground, all right? So we cover it with paint and we roll it one time. When we roll it one time, you look down and what do you have on the ground? You have a straight line, and you're going to have a straight line the exact same distance as the circumference of that tire. Or you could think of it as taking the tire, cutting the tire in half on top, spread it out to make that straight line. Okay, that straight line is the same distance as the circumference of the circle because that's your perimeter around the circle. So the bike tire goes 600 times and that takes it 10,000 pi inches. Now, I know it's weird to look at pi inches, but it's going to actually make this problem a little easier down the road here. So 10,000 pi every 600 revolutions. We can simplify this to find out how far it goes just one revolution. I'm using the calculator on this one. I don't have an Owen with me today. I don't know if he could do that one in his head, though he probably would. All right, 10,000 divided by 600 gives us 16.7 pi. Don't forget that pi is still there, okay? Inches. That is our circumference of the bike. So now I can set that equal to our circumference equation and solve it for the radius, okay, that we can convert back to the diameter. 16.7 pi is our circumference for this tire. That's 2 pi r. We want to solve for r. Oops, pi. Have to divide by what's being done to r. It's being multiplied. Now on this side, our pi's actually go away. So when I said that was going to come in handy later on, that's why. It actually cancels out. 16.7 divided by 2 is 8.35. No more pi. It is still, however, in inches. And then our diameter is 2 times our radius. So 6.7 or 16.7 inches. Okay, that is the answer. That is our diameter of that wheel. So 8 and 8. We are given that AED is equal to 40. So I wish I had more colors. I need to buy more markers. AED, so that's this triangle right here, has an area of 40 inches squared. We can use that fact to figure out these other sides. So I know 40 is equal to 1/2 the base of AED, which we don't know, but it would be useful to know because it's the base that we're looking for. So because of that, I'm going to call it B with a little 2, just because that is base 2 of the trapezoid. It's also happening to be the base of the triangle they gave us the area of. And then our height on that triangle is 8. So simplifying this out and not writing the units, I have 40 equals 1/2 times B2 times 8. Well, 1/2 of 8 is 4. B2, divide both sides by 4. And 10, okay, that canceled, is equal to B2. Okay, and that's in inches. We have to keep that in mind for our answer. So I can plug in our B2 as 10. And again, we found that using the information they gave us about AED. It happens to share a base, that triangle with the trapezoid we're looking at. So 8 plus 10 is 18 over 2 times 8. That becomes 9 times 8 is 72. And we are in square inches, okay, or inches squared. Yay! See, that wasn't that hard. Really, it looked harder than it was.